Hi, I'm Rob. Welcome to my channel. In this video, I'm going to talk about how I built the state machine for my upcoming game, Exposure, a photography game where you compete against your friends for the best photo of different creatures. My creatures share most of the same behavior with some key differences, being fleeing versus chasing or attacking. Therefore, I built my AI behavior through inheritance, and each creature will override the default behavior. Before writing any code, I sat down and listed out what I needed these creatures to do. They need to wander around naturally when nothing's happening. They need to react to sounds, a footstep, a camera flash. When they hear something, they should stop, turn toward it, and watch for a moment. If they see the player, they need to make a decision, and that decision depends on the type of creature. So straight away, I can see there's a clear set of states these creatures are in at any given time. Wandering, alert, chasing, fleeing, and a few others I'll get into later. The logic for transitioning between those states is shared across all creatures. They all hear sounds the same way. They all have the same vision system. What differs is what they do when they detect a threat. That observation is basically what drove the whole architecture. So here's what I landed on. Two classes living on the same game object. The first is the AI controller. It owns the state machine. It knows what state the creature's in and drives the update loop and holds shared parameters like sight range and hearing. Completely creature type agnostic. It has no idea whether it's attached to a deer or a predator. The second piece is an abstract base class, creature behavior base. This is what the concrete creature classes inherit from. And one of those is what lives on the game object alongside the AI controller. The base class handles the shared logic for every state: wander, alert, flee, and exposes exactly 3 points where a subclass can customize behavior. What happens when a player is detected, what happens when the alert timer runs out, and what happens on attack. The first two are virtual, with sensible defaults already built in. Flee when detected, go back to wandering when the alert timer runs out. Attack is abstract. There's no sensible default built for that one. So any creature that can actually attack has to define it itself. Concrete types only override what's actually different. Everything else they get for free through inheritance, which means adding a new creature type is maybe 10 lines of code, touching nothing else. That's exactly what I was going for. The first thing I did was just define the states. These are the 7 states a creature can be in at any given time: idle, wander, alert, investigate, chase, attack, and flee. Next come the core properties and awake. Notice that the controller holds a reference to the behavior component and not a specific creature type. It just knows it's some kind of creature behavior base. That's the separation I needed. Then the update loop and enter state, which is the heart of the whole machine. Every frame, the controller asks the behavior to handle the current state, and enter state is the only way to change the state. It always fires the onEnter method so the behavior can set up whatever it needs for that state. So that's the AI controller. Now for the behavior base class. This is where the actual logic lives. Every state has an enter method and an update method. Enter runs once when you transition in. Set a destination, reset the timer, whatever that state needs to set up. Update runs every frame and handles the logic for staying in or leaving that state. Starting with idle, it does 2 things every frame: check if the player is visible and check if the timer has run out. That's it. If either condition is true, it transitions out. If neither, it just stays here. Wander is the same shape as idle. Enter picks a random destination on the nav mesh and starts walking. Update watches for the player or checks if we've arrived. When we arrive, go back to idle and the cycle repeats. Alert is where hearing actually connects. It's the suspicion state. The creature heard something, so it stops, turns towards the sound, and watches. It has a window of time to spot the player. If it does, undetected fires. If the timer runs out without a sighting, on alert timeout fires. Both of those are decision points that subclasses will override. These three are the personality of the creature. Undetected and on alert timeout have defaults: flee and wander. On attack is abstract because there's no sensible default. Every concrete creature must decide what attacking means for it. A fleeing creature can just leave it empty. A dangerous creature will deal damage. That covers the base behavior class. Now, the behaviors call can see player every frame, and creatures can be alerted by noise from anywhere in the scene. You'll see two similarly named methods here. Can see player is the one the states call every frame and finds the nearest player automatically. Can see target is a lower level check underneath it, used once a specific target is already known. Now the other half, hearing. Every creature registers itself in a static list when it spawns. When anything makes noise, a footstep, a camera flash, it calls notify noise with a position, radius, and intensity. The method loops every creature in the scene, skips ones that are already fully engaged, filters by intensity threshold, then checks distance. If all checks pass, the creature goes to alert. The intensity threshold is what lets you tune how sensitive a specific creature is. Crank it up and it barely reacts to anything. Set it low and it hears everything. So that's the sight and hearing. Now here's where all of that architecture pays off. Let's build two of the creature types. First, the dangerous one, a predator that chases and investigates. This one differs from the defaults, so it needs to override the decision points. Undetected goes to chase instead of flee. On alert timeout goes to investigate instead of just wandering off. This creature goes and checks where the sound came from. And on attack is where I'll put the damage logic. Everything else, the wander cycle, the alert behavior, the sight checks and chase and flee movement, all inherited. And now the harmless one, a creature that just flees when it sees you. Watch how little this takes. That's it. That's the whole class. It inherits everything from the base: wandering, alerting, fleeing on detection, going back to wander after alert. The only thing I had to implement is on attack. So that's the whole system. If you want to see the full source of any of these files, I'll link them in the description. Let me know in the comments if you've built something similar or if you'd approach it differently. And thanks for watching.